The broadcast is now starting. All attendees are in listen-only mode.
Okay, good afternoon, everybody. Welcome to our ShapeBlue webinar on using Nextgen's storage to improve performance, scalability, and efficiency in your CloudStack infrastructure. My name is Giles Sirett. I'm CEO of ShapeBlue. If you want to follow me on Twitter, I am at ShapeBlue. Great turnout today. We've got lots of people from lots of different corners of planet Earth turning up to listen to this. Hopefully we're going to give you some really good educational content to listen to. In terms of what we're going to be talking about today, we're going to have a look at some of the design considerations for when you're building out an IaaS environment based on CloudStack. And when I say CloudStack, that's either Apache CloudStack or Citrix Cloud Platform or any other commercial distribution you may have. Going to dive down and look at the implications around primary and secondary storage, and then importantly how we scale that storage. We're going to talk about one of the big challenges we face. We call it the IOPS dilemma here at ShapeBlue. It's one of the big problems we have when designing these environments. And then we're going to talk through some real-world storage scenarios. We're going to look at a couple of real-world use cases of customers and the challenges we faced when actually designing scalable and efficient storage for them. We've also got some guys from SolidFire on the webinar today. I'll introduce you to those guys in a second. And they're doing some really innovative stuff, and we're really quite impressed with their technology. We worked with them on a couple of projects. So we're going to let them tell you about the things they're doing to help address some of the challenges that we're currently facing. And right at the end, we're going to have a look at an actual live demo of some of the work we've been doing. Right at the end, we're going to do a Q&A session. We'll leave about 10 minutes for that. I'll explain to you how to actually ask questions in a second. So who have we got on the webinar today? There's me, top left, with a very artistic black and white photo. I'm CEO of ShapeBlue. We've also got Geoff, who's our CTO, who's sat here on GoToMeeting, primed and ready to go. We've got Mike from SolidFire. Mike leads up the integration work that SolidFire are doing with CloudStack, and has actually been one of our sort of primary touch points within SolidFire, because obviously as an organization we do a lot of work with CloudStack, and it's really good to get that sort of direct relationship with the guy who's actually doing a lot of the work. We've also got McClain Buggle from SolidFire as well, Mac, who can talk about how SolidFire is positioned to address a lot of the problems we have when building cloud environments. In terms of questions, I'm sure most of you have been on a webinar hosted on GoToMeeting before, but if you haven't, if you look in the control panel, there's a question button somewhere you can click Ask Question. If you do that, we then all get visibility. All four of us can see those questions. The only thing to say is, please, if you've got a question as we go through the webinar, please, please, please ask that question straight away. Fire it off so we've got it. We probably will look at it there and then. We'll probably leave it till the end to talk in the Q&A session. But please fire those through so we can see those questions as they're coming through, instead of getting 200 questions firing through right at the very end. So just very quickly, just a little bit about our organization. ShapeBlue as an organization, all we do is build IaaS cloud environments based on Apache CloudStack and Citrix Cloud Platform. We're a pure play CloudStack shop. We build these environments, we consult around the technology, we train people around the technology, and then we support those environments afterwards. I think what I'm trying to get over here is that as an organization we are reasonably qualified to talk about some of the design challenges faced when looking at storage for a CloudStack environment. And again, just to give you an idea, these are some of the organizations we've worked with in the last year, some very large organizations, and we've worked on some of the world's largest CloudStack builds, some very significant public clouds, and increasingly a lot of private and hybrid cloud use cases from a more traditional enterprise focus. We're based, I'm talking to you from London, from a very cold London this afternoon, but we've got our offices out on the West Coast, down in Brazil, and over in India as well. So that's just a little bit about us. Okay, before I hand over to Geoff to start going into the details of design considerations, I just wanted to do a very quick 2-minute primer on CloudStack and what it is and how it's positioned. Now, looking at a lot of the people who have registered for this webinar, I know a lot of you guys are already familiar with CloudStack as a technology, as an orchestration platform, but there's also a lot of new names I don't recognize. So what I want to just do is just go through a very, very quick CloudStack 101, more than anything just to get the terminology in place for you before Geoff starts talking about design considerations. So CloudStack is a piece of software that lets us orchestrate and build an infrastructure as a service layer, pretty much like Amazon Web Services, EC2, Elastic Compute Cloud. What we do is we take storage, network, and compute at the bottom. We put a hypervisor over the top of that. CloudStack is relatively hypervisor agnostic. It will support most hypervisors that people want to work with nowadays. We put CloudStack over the top. CloudStack then presents a REST API, and this is a very important play because people don't just want a GUI for users to go and provision infrastructure components. They want an API so developers can do that, or tooling that sits on top of that orchestrated environment can do. So on top of that API, what we would commonly find, if it's in a public cloud environment, we'd find some sort of business operation or e-commerce platform for actually selling the infrastructure as a service components, billing component, maybe management tools on top. And then in a more traditionally a private or a hybrid environment, we might find a PaaS layer being put on top, developer tooling, and then maybe multi-cloud management nowadays for workload bursting, that sort of thing. So that's the role of what CloudStack actually does as a technology and where it sits in the grand scheme of things. In terms of some key terms around CloudStack, some key concepts, we've got 4 different sort of points of scale. We start with a region, which is analogous to an Amazon EC2 region. A region is normally a geographic area. Think of it as a continental area, or it could be a state within the US or something like that. A zone is normally analogous to a data center, a zone like an Amazon availability zone. And key point is, this is where we first see the concept of secondary storage. So secondary storage in CloudStack is zone-wide. I'll explain what secondary storage is in more detail in a second. Underneath the zone, we have a pod that normally equates to a physical rack in a data center. That's more important as a unit of scale from a networking perspective than a storage perspective, but it's normally one of the key units of scale we take because a lot of organizations want to actually scale out rack by rack by rack, so pod is a logical place to do that. Inside a pod, we have a certain number of hosts, compute hosts, and those hosts have primary storage. Now, primary storage is, again, I'm going to talk about that in more detail in a second. Primary storage can be shared storage, or it can be local storage on those hosts. And that's down at cluster level. So they're the 4 key sort of definitions, if you like, in terms of a CloudStack infrastructure. Secondary storage, as I said, sits at zone level. Secondary storage is used for the more static artifacts in CloudStack. So secondary storage is used to store templates, ISOs, snapshots, etc., etc. It has to be based on NFS. It's not usually key in the performance of a CloudStack infrastructure. So the general rule around secondary storage is we're looking to make it as cheap as possible. We need often quite a lot of it, so we look to do that with relatively low-cost technologies. Okay, we can back it off now with CloudStack out to either Swift or S3 to actually be able to share those artifacts between zones. In terms of scaling secondary storage, it's relatively straightforward because we look to do it as low cost as possible. The capacity planning around secondary storage is based on the number of ISOs we have, the number of templates we have, then the things consumed by our users, whether they're public cloud users or users in a private cloud. So the number of templates they're having, the number of snapshots they have, etc., etc. And that's some pretty straightforward, old-fashioned capacity planning that we have to do around secondary storage. Of much more concern when designing a CloudStack environment is getting the primary storage right. The primary storage sits at cluster, or in newer versions of CloudStack can sit at zone level, but we tend to think of it still as sitting at cluster level. And primary storage is used to actually run the virtual machines. Okay, it stores all the disk volumes and also VM snapshots for VMs in more recent editions. So primary storage is where the performance bottlenecks are going to occur, is what we always see. It's the bit that we need to get really, really right in terms of storage. Now we can use NFS, iSCSI, Fiber Channel, lots of different options, but the key thing with our primary storage is we've got to get that balance correct in terms of performance, in terms of what our users or our customers need, and balancing off against the cost in terms of, you know, if we're a public cloud provider, making up our cloud profitable, and also from a scalability viewpoint. So that's just a very quick primer in terms of some sort of key CloudStack ideas. I'm now going to hand over to a man who knows what he's talking about, who's Geoff, our CTO, and Geoff's going to start to talk about some of the design considerations when choosing storage. So, Geoff, are you on the line?
I am. Thank you very much for that intro, Giles.
Cheers. Over to you. I'm going to press mute and drink my coffee.
Okay. Right, so Giles has set the picture very nicely there. Thank you, Giles. And what I'm now going to drill into is a bit more in-depth, focusing on what you consider when you're designing primary storage. So my key day job is actually designing various CloudStack architectures, whether they're enterprise or private clouds, public clouds, sorry. And obviously a big section of that design piece is actually working out what storage we're going to use, how we're going to configure it, how we're going to scale it, how we're going to deploy it, etc. So the key thing you need to think about when you're designing your storage is the workload. Workload in most clouds dictate the whole architecture, and very much so when it comes to the storage architecture. Now, when we do an enterprise cloud, that's normally quite easy. We know exactly what the work is going to be. We can work out the metrics of those VMs that will be running on there. That's great. When it's a public cloud, however, we have no idea. It's public. End users could create VMs of any style, any size, any capacity. We just don't know. So you really have to design for every possible scenario. Now, the key things we need to look at there is the scale of the VMs, how much capacity they are going to be using. An end user will often specify that they want to build their cloud based on X number of gigabytes per VM, and the IOPS performance is the next key measure there, and we get told, or we get advised, that we need to allocate a certain amount of IOPS per VM. So the two key driving factors are the capacity for the VMs and the actual disk performance, in other words, IOPS for each VM. Now, in the ideal world, if we're using, say, iSCSI LUNs, we would make those LUNs quite small, and we would allocate around 20 VMs per iSCSI LUN, because that will give us optimal performance for those VMs. Now, the only problem with that is that that requires a lot of admin overhead, and creating those LUNs, managing those LUNs, assigning them to CloudStack, and it's all a manual process, and it's very labor intensive. So unfortunately, the easy way out of there today is that what admins do is they create larger LUNs, say 6 or 8 terabytes, and let the VMs fight it out for performance that they can get from those LUNs. So we have problems with performance, and then every time we try to scale out, add more storage, we have to create more LUNs, assign to CloudStack, configure them as primary storage, and it's a vicious cycle of things getting bigger, lots of admin, lots of overhead. Not the ideal world. Now, if we actually look at CloudStack, it's all about orchestration. You know, CloudStack is a central device that orchestrates our whole architecture. So when we're building cloud systems, we want to use devices, components, which can be orchestrated by CloudStack. We need that scale. So currently, CloudStack can orchestrate the hypervisors. It can orchestrate the networks, especially if we have SDN, software-defined networking. It completely takes control of what's going on at the network layer. We can orchestrate various appliances like F5 load balancers, Juniper SRX firewalls, Citrix NetScalers. We've got UCS integration now. The key thing is that CloudStack is orchestrating all of these devices, and of course it's orchestrating the virtual machine as well. It's creating them, stopping them, starting them, making them move between hypervisors, etc. So we're seeing a common denominator here. CloudStack orchestrates the components of our cloud. So storage is a major part of our infrastructure. It's crucial to the performance of our infrastructure. It's crucial to how it all works. We therefore should be choosing a storage vendor that CloudStack can orchestrate. Traditionally, this hasn't been the case. There hasn't been the options for orchestrating storage with CloudStack. We've now got options coming on stream, and we're going to look at one a bit later with the SolidFire solution. It just makes logical sense that the storage should be orchestrated by the orchestration engine, which is CloudStack. It simplifies management, simplifies deployment, and lets us build at true cloud scale. So just going to give you a theoretical example here of how we're going to go about scaling our storage. So we said here earlier that we've got two components, the size of the storage and the performance. So I've got based on real world figures here, but an example of some of some compute hosts. So this example is based on 4 Zen server clusters, each with 4 hosts. The reason there are only 4 in size is because a LUN can only handle so many connections. Sorry, a cluster can only have so many LUNs in it, and therefore keeping the clusters reasonably small means that we're not going to max out the maximum number of LUNs per cluster. These are actually 4-socket servers, which is a scenario or a configuration we're seeing more and more being used nowadays, rather than the traditional 2-socket servers, because it gives that sort of true scale in a data center. You could easily replace this architecture there with 8 clusters, each with 4 hosts at 2 sockets each, with the same overall CPU memory. So once we've allowed for overhead of the actual hypervisors, in this case Zen server DOM 0, and memory used by the hypervisor, our total capacity is 28 cores and 760 gig per server. And working on a mapping of 6 virtual CPUs to 1 physical core, which is generally accepted as best practice to give you reasonable performance and maximum use of your architecture. So that's the sort of the physical underlying architecture we have that we're working on. So we then frequently get asked to base our scaling metrics on an average VM spec of 1 vCPU to 4 gig of RAM. Now, we know in the real world they're often larger and smaller and different configurations, but this is time and time again the specification we get told by our clients to say, for scaling, please use these calculations. So that's the example I'm going to go with. So given our host capacity that we have of those 4 hosts with X memory of CPU memory, what we could basically deploy in this theoretical scenario is just over 2,500 guest VMs. Now, those VMs have been allocated 30 IOPS each and a 20 gig root volume effectively. So we've got 50 terabytes of storage and 76,000 IOPS. Now, we've also allowed in this scenario the overhead of the virtual routers. That's quite important. People often forget that in a CloudStack cloud multi-tenant, we have lots of networks, lots of virtual routers. They have overheads, they need CPU, they need disk IOPS. This scenario is based on a public cloud offering where we've got the redundant virtual routers enabled. So there's 2 virtual routers per network, and I think I've worked on 4 VMs per network. So they in turn need 12,000 IOPS and another 2.5 terabytes of storage. So in total, what we actually need is from our storage device, 53 terabytes of capacity and 88,500 IOPS. So that's our requirement. Seems quite straightforward. The gotcha is, and we've hit this problem time and time again, we then go out to vendor X, Y, Z and get a storage array spec'd out. We hit 50 terabytes quite easily, but that's only given us 9,500 IOPS. And that's probably an optimistic estimate based on tiered storage, SSDs, RAM caching, lots of memory, and fast spindles at the bottom layer. So multi-tiered storage, high-end storage solutions, we're falling way short on the IOPS. So the only answer, unfortunately, is we need more storage. So we would deploy multiple storage arrays in order to get the IOPS we need. And in this scenario, we had to deploy 10 storage arrays in order to get the IOPS that we require. If we deployed 9, we'd have been falling short the IOPS. 10 gives us the IOPS we need. So here's a problem. We've now used 10 times the capacity in order to get the performance that we need to give reasonable performing VMs. And this is not a made-up example. It's a real-world scenario we hit time and time again. Here's an excerpt from a design document that we've done. I've replaced the vendor names and the models just to keep it sort of generic, but this is a real design document that we've developed or we've issued to a client specifying their storage solution. Now, when we came on board, they'd chosen one storage architecture. When we analyzed it, it was way under spec performance-wise. It got replaced with a second storage solution, cost more money, and the vendor concerned gave us these metrics. So again, they said, this solution will give you 9,500 IOPS. It will give you 50 terabytes of usable storage space. And it's a HA active controller, so it's a nice high-end solution. So their requirements for that particular solution was they needed for their VMs to run on that storage 12 terabytes of storage per 19,500 IOPS. That was real-world metrics. That's what they needed. The solution was we had to put in storage capacity of 100 terabytes, 19,000 IOPS to provide that one cluster scenario. Now, they actually supplied or required 6 of these storage arrays for their scale, which resulted in half a petabyte of wasted capacity. So massively over-specifying the amount of storage that's required because the number of spindles you have dictates the IOPS. Yes, we've got caching, yes, we've got tiered storage, and that all helps, but at the end of the day, spindles have a finite IOPS performance, and what we're constantly doing is time and time again is we're over-specifying capacity to meet the performance requirements. Here's another example of another design document, this time for an enterprise cloud, and there's a statement at the bottom of this section, the last paragraph, really is basically saying that we're going to massively over-specify the storage capacity in order to meet the requirements of your performance. This is just something that's happening week in, week out, and we're wasting a lot of money buying very large amounts of storage that we simply don't need. Now, it gets worse. So the way CloudStack deploys VMs is it actually uses a concept called linked clones. So every time we create a new VM based on a template, it doesn't actually copy that template in its entirety. It basically creates the VM as a linked clone to that template. This means that if we have, for example, a template that has a 20 gig root partition allocated to it, so when it was installed it was created as 20 gig, it was pin provisioned, so it actually is only using 2 gig of disk on the actual storage array. Now if we create VMs linked to that storage, it doesn't create a 20 gig disk, it doesn't even create a 2 gig disk, it creates a 200 megabyte disk. So only then when that VM starts to generate unique data like log files on a web server does it actually grow. So we've specified a storage capacity based on 20 gigs per VM, when actually we're looking at a few hundred megs per VM. So that 10 times storage over capacity, more like 100 times over capacity. It gets even worse. Thin provisioning on the storage array helps keep the size down. It means we've got even more wasted disk space. And any decent storage solution nowadays will have dedupe. That just makes the storage used even smaller. So the difference now between the amount of capacity we're using on the storage array compared to the amount of capacity it's got to give us the IOPS just gets bigger. So the actual storage you need is much, much lower. So in summary, we've got to think about the amount of IOPS per storage array, not per VM. So giving a VM 30 IOPS is easy. Giving 1,000 VMs 30 IOPS at the same time is not easy. Think about the IOPS at the storage array level. Traditional multi-tiered storage has its limits. They're all doing it now. We've all got these clever ways of increasing IOPS and using large caches to improve performance. But at the end of the day, the underlying architecture is a bottleneck. Spinning disks and the way that the RAIDs are configured and the way that data is moved around the actual storage arrays is giving us problems that we're trying to overcome. We're being forced to have extra capacity to achieve the IOPS. And I've given you some real-world examples there of what we're doing at the moment to actually achieve this. Things like deduplication actually make our life harder. So that's the real-world problem. That's where we're at today. We specify the storage capacity and the performance based on the requirements of customers. We then look at the hardware available in the market and we choose the best option. And some examples of what we have done, we've chosen different storage vendors, different solutions to meet the requirements, and have always ended up putting far more hardware than we needed. Now, coming up next is McClain from SolidFire, and what they're going to hopefully show us is that they've got an alternative way of doing things, a smarter way of doing things, and let's see what they've got to say about how their SolidFire solution works with CloudStack. So, McClain, over to you. I shall pass control.
Very good. Thanks, Geoff. I really appreciate the opportunity to talk about how SolidFire fits into this design process. So I will go ahead and share my screen here. Hopefully we are good now. Okay. Again, my name is McClain Buggle. I handle solution marketing for SolidFire. SolidFire builds an all-flash scale-out storage system designed specifically for cloud environments. So at a high level, the system scales horizontally with your cloud. It has built-in data protection to deliver high availability. Unique to SolidFire is the ability to guarantee IOPS on a per volume basis. And to maximize capacity, some of the points that Geoff was just making, we leverage techniques like deduplication, compression, and thin provisioning to maximize the capacity and minimize the footprint. And also to Geoff's point, when it comes to maybe one of the most important things when it comes to a cloud environment is automation. SolidFire is designed from the ground up to be fully automated, and this is enabled through its REST-based API. So I'd like to dig into each of these just a little bit further. Won't spend too much time on each one, but I just wanted to give you the highlights here. So the SolidFire system scales by adding nodes as needed. So each node provides additional performance and additional capacity. You can scale these nodes one at a time on the fly without any downtime. And so if you take our example here of the SolidFire 3010, each node provides an additional 12 terabytes of capacity and 50,000 IOPS that can then be pulled into the cluster and provisioned out independently. This type of architecture really makes it simple, really simplifies the design process because it gives you the flexibility down the road to adjust. SolidFire is a highly available storage system. It automatically distributes the data across the entire cluster. There are no single points of failure, and the system is completely self-healing. So if there is any kind of hardware failure, the system will automatically redistribute the data to the available nodes. Also, a nice important feature here is to think about is as new software features become available, you can roll the updates onto the SolidFire system without any downtime. And the reason I pointed out these topics and potential issues are these are the issues that you will be facing during the design process when you're scoping out your cloud, and you need to take these into account. Unique to SolidFire is the ability to provision out capacity independent of performance. With SolidFire, this is extremely simple. You simply say how large and how fast. When it comes to performance, you specify. You have the opportunity to specify a minimum, a maximum, and a burst level of IOPS that the SolidFire system will guarantee to that volume across all volumes. Really makes it ideal in a shared environment where you have multiple tenants or multiple customers. You can tailor the performance to each customer or each by volume, and really ensure that they get what they need. And Geoff pointed out the capacity, performance and capacity problems earlier to help address and maximize the capacity side of the equation. SolidFire leverages deduplication, compression, and thin provisioning in line. It's done globally across the entire cluster, and it's done, most importantly, without any performance impact to the system. So this really reduces the power, cooling, and floor space required. I think highlighted at the beginning here is that automation is critical to scale. You just cannot scale if you can't automate the process. So every action on a SolidFire system can be automated. And in fact, when it comes to CloudStack, we've built a plugin that we've provided upstream and put into the CloudStack orchestration software that allows CloudStack to manage SolidFire directly. And in a minute here, I'll hand it over to Mike, and Mike will do a demo of CloudStack provisioning a volume with guaranteed performance. So to wrap this up, SolidFire was architected from the ground up to be used in cloud environments. It has the feature set necessary to work with the cloud orchestration platform here. And I wanted just to point out that this is just extremely difficult when it comes with traditional storage. I think Geoff hit on all the right points here. They're really dual controllered in nature. It is not too difficult to add capacity. You just simply add disk shelves with traditional storage systems. But the challenge comes when you want to increase performance. There's really only one option, and that is to significantly over-provision the storage and then leave yourself with a significant amount of capacity that must go unused because the performance is being used to deliver the cloud VMs. So at this point, I want to hand it over to Mike. Mike is going to provide a demo of provisioning SolidFire through CloudStack.
Great, thanks, McClain. So in a moment,
I'm going to hand it over to you.
Great, that sounds good. So what I'm going to be demoing here is the SolidFire integration into CloudStack. This is a plugin which enables system admins to offer to end users the ability to guarantee IOPS on a per VM basis or a per data disk basis. So just to kind of jump in here and give you a little bit of overview, I have just a single cluster in this CloudStack installation running one Zen server host. What I'm going to focus on here is the primary storage component. So about in the middle row there, I'm going to click on primary storage. We can see there's two rows in this table. The bottom row is the local storage for the Zen server host that I have in my cluster. What we'd like to look at here is the top row, which is primary storage that was added based on the SolidFire plugin. One of the points I'd like to note here is the scope field, which is at the zone level. So I believe Giles or Geoff mentioned earlier, prior to the 4.2 release, all primary storage in CloudStack was at the cluster level. As of 4.2, we're now offering zone-wide primary storage. So this primary storage that I've added based on the plugin is now available to hosts across the entire zone, as opposed to being tied to a specific cluster. I'm going to click on the first row and drill down into some of the details. This is pretty much, if you're familiar with primary storage in CloudStack, this is going to look very familiar. All of the normal fields apply to this kind of primary storage as well. The storage tags field, I'd like to point out, SolidFire SAN1, that'll come into play later. We can see that it's at the zone level. This is iSCSI storage. And I've given CloudStack about 2 petabytes to play with and about 4.5 million IOPS. So in this case, as opposed to the traditional way primary storage worked in CloudStack, where you pre-allocated, say, 6 to 8 terabyte volumes, and you handed them over to CloudStack, and then CloudStack would lay a whole bunch of root and data disks on the same 6 to 8 terabyte LUN. In this case, what we're doing is we're actually handing CloudStack a subset of the storage area network. So not a pre-allocated volume, but rather a subset of the SAN. And in this case, about 2 petabytes, 4.5 million IOPS. All right, so once we've got primary storage in place, we can come over to the Service Offerings tab, and let's go over to the Disk Offerings section. This disk offerings are what allow you to define characteristics for volumes that can be created within CloudStack. So what I'm going to do is click on the Add Disk Offering button in the upper right. We can fill in a name, a description. In this case, we're actually dealing with shared storage as opposed to local storage. I'm going to just throw in a generic size here. The point that I'd like to mention in this disk offering dialog that's new to the 4.2 release is this QoS type field. What I'm going to do here is select the combo box and pick storage. In this case, we see a few new options. The ones I just want to point out are the min IOPS, which we can fill in, and the max IOPS. So in this case, when someone actually executes this disk offering, they'll receive a volume on the SolidFire SAN that has a guaranteed minimum of 200 IOPS and will typically top off at 300 max IOPS. So the point to note here is that every CloudStack volume can now be tied in to a single volume on the SolidFire SAN that has guaranteed IOPS. So regardless of what your neighbors are doing, they cannot impact your performance. So for the sake of time, I'm going to actually cancel out of this dialog and just point out the fact that I've already created a disk offering which has 200 min IOPS and 300 max IOPS. And using this disk offering, I want to move over now to the Storage tab, and I want to show how you can create a volume that's based on this disk offering that has guaranteed IOPS. What I'm going to do is go to the upper right, the Add Volume button. We can fill in a name. As is the case for volumes in CloudStack, you pick an availability zone. The area that I want to focus on here is the disk offering combo box, which is at the very bottom of the dialog. I'm going to select that offering and pick the SolidFire based disk offering that has 200 min IOPS and 300 max IOPS. And again, for the sake of time, I've already created such a volume based on this disk offering. So what I'll do is I'll cancel out of this dialog, and I'll show you the first row in the table is a volume that is created based on this particular disk offering. It has 200 minimum IOPS, 300 maximum IOPS. So at this point, we've got our CloudStack volume. There's nothing actually created on the SAN until you first attach this volume to a VM. So let's go ahead and do that now. I'm going to go under the Quick View column and click on the Attach Disk button. And I only have a single virtual machine running in this particular CloudStack environment, so I'll select that. At this point, what's happening is the SolidFire plugin is going off to the going off to the SolidFire SAN, and it's creating a volume with 200 minimum IOPS, 300 maximum IOPS, and it's arranging everything else that needs to be done on the SAN, such as setting up counts and permissions. We can actually walk over to the SolidFire GUI right now and take a look at its progress. I'm going to click on the Volumes tab, and we can see here our volume 1 was created. If I go look at the details for this particular volume, we have 200 minimum IOPS, 300 maximum, which is what we specified. Come back over here, we can see now that the disk, the CloudStack disk, which is based on the SolidFire volume, has been attached to our virtual machine. And just for a second, I'm going to jump into Zen Center to demonstrate what happened here. What I've highlighted is the virtual machine where we attached the new disk to. This virtual machine has, in the pane to the right, we can see it has a root volume, of course, but of more interest to us is the position 1 volume, which is 1 gigabyte in size. That is the CloudStack volume that we just created on the SolidFire SAN, and this is the volume that you can leverage with 200 minimum IOPS, 300 maximum IOPS, and not worry about what your neighbors are doing on the SAN. We could do this repeatedly. We could make more SolidFire volumes based on CloudStack volumes, attach them to this virtual machine or to other virtual machines. Just depends on what the need is in your particular environment. So yeah, that basically concludes my my demonstration here. So Giles, perhaps.
Yeah, I'm here, Mike. Are you going to pass control back to me?
Let's see. I believe you
or should I? I'll steal it back off you. Should I?
Yeah, steal it back. And then
there we go.
My right click is having trouble. Thank you.
Okay. Okay. Thanks for that, Mike. That's a really good demo. So we're sort of getting towards the end of this webinar now, but there's just some key points there in terms of, you know, the points that Geoff's making around the issues we have when designing CloudStack clouds, and actually you say CloudStack clouds. This isn't just CloudStack clouds. This is orchestrated clouds. This is clouds that need to scale very quickly and scale horizontally. And you know what we do find is that everybody understands the concept of horizontal scale nowadays, but actually putting the physical tin in place to make that happen in a cost-effective, sensible, rapid and agile way isn't always possible with some of the existing technologies we've got out there. And the other thing just to highlight from what Geoff said there was that if we think about an IaaS orchestration tool like CloudStack, it can orchestrate the three components: compute, networking, and storage. And until recently, we've talked about those three things, but actually it's really the networking piece through CloudStack's sort of networking as a service model and the compute through the hypervisor that really CloudStack has automated. The storage has just been a dumb thing that we've connected to and we've used to run our virtual machines and to store our artifacts. But having that level of integration and automation that Mike and the guys from SolidFire are showing us, that's what's really exciting us here at ShapeBlue, because that's all about reducing man hours and therefore cost when you go to horizontally scale. And that's a key thing. Anybody can build a cloud that can scale, but can it scale quickly, and can it scale to a really good price point if you're a public cloud provider or even in a private cloud environment. So it's great to see SolidFire not only having some very innovative approach to being able to get some decent IOPS performance out of their storage without having to buy a gazillion terabytes. But it's also great to see SolidFire realizing that their storage needs to be used in an orchestrated cloud environment, and therefore to do that integration. So that's really great. So I've got a few questions that have come through, guys. Probably best if you all sort of unmute your mics, and then we'll choose between us who's going to take these questions. So the first one comes from Jax. Does OpenStack overcome these issues? That's a really good question to start with. I'll take that one. OpenStack is a very similar technology to CloudStack. As at ShapeBlue, we focus on CloudStack. The short answer is no. These issues aren't around what orchestrator you use. These issues are around the underlying physical infrastructure, the storage, the network, and compute that you have to actually provide that cloud. So the short answer to that one is no. So Bartesh, when would you use local storage over shared storage? Geoff, do you want to discuss that one?
Sorry, could you repeat the question, Giles?
Yeah, when would you use?
See the list of questions.
Yeah, when would you use local storage over shared storage?
So one use case there that we've actually seen in the wild, so to speak, was actually two enterprise use cases. One where their complete cloud architecture was cloudy, so all the applications had been built to actually be true cloud-based applications, and the designers are basically told, you build your apps to run on host and treat the host as a single point of failure. So the app's always deployed across multiple VMs, across multiple hosts, so that if one hypervisor goes offline, the VMs that are running on there will die because they're using local storage, but the application that those VMs are powering will not be affected. In that scenario, you don't need the expensive shared storage because your single point of failure or your high availability touch point is the host rather than the storage that's providing that host layer. So if your VMs are multiple instances, you can use local storage. If you're using more traditional workloads, where you need the VM to stay online, you then need the shared storage so that you can fail over that VM to a different host in the event of a failure and keep the application that's running on that VM active.
Okay, great. Thanks for that answer, Geoff. Next question is from David. Are the design considerations the same for private cloud and public cloud? I have some thoughts on that. Anybody else fancy? Geoff, do you want that one again?
Give me the question again, sorry.
Yes. let me answer. Yeah, okay. So are the design considerations the same for private cloud and public cloud? I mean, okay. So in short, yes, we've got the same storage. You know, we're talking about storage here today. The same storage considerations there. I think the key point was what Geoff touched on earlier, which is in a public cloud environment, you just don't know what the workloads are going to look like. In a private cloud environment, we stand at least a chance of being able to analyze and look at what the workloads, you know, are they going to be IOPS intensive, are they not, et cetera, et cetera. And this isn't just for storage, this is for other aspects of a cloud. So yeah, it's the same issues apart from we're relatively dark normally in a public cloud environment in terms of understanding things.
So, Giles, in that scenario, you need to actually build, therefore, your cloud almost for the worst case scenario. So you need to almost over-specify the storage performance and IOPS and capacity because you just don't know what's going to come along.
Yeah.
So the difference is if you don't know what's coming, you've got to build for almost every scenario, which makes it even harder.
Sure, and Mac, yeah, if you're still on the line, you know, something you guys talk about at SolidFire is this concept of noisy neighbor, right? That's something that you've identified as a problem. That's certainly something we've seen. Do you want to sort of go over that again?
Yeah, absolutely. So when it comes to the noisy neighbor, you know, private cloud, public cloud, you're in a cloud environment. You have multiple customers, multiple tenants. Noisy neighbor is a real issue. You can't necessarily control and ask customers who have designed their application to limit themselves. And so, you know, one of the biggest advantages of SolidFire was to find a way to isolate that naturally and also provide methods for them to ensure or guarantee a level of performance, but allow them to peak or burst as needed as resources were available. So public or private, the situation is real and needs to be planned for and addressed.
Sure. Okay, thanks, Matt. So the next questions come from Abdul, which is this relevant to Citrix Cloud as well as CloudStack? So Abdul, I'm going to take a stab at what you mean by that question. I'm guessing you mean Citrix Cloud Platform, which is their commercial distribution of Apache CloudStack. In short, yeah, everything you've heard here today is relevant because the two products are identical code base. It's just Citrix do a sort of support piece around Cloud Platform. But actually, Mike, from your perspective, your sort of integration points, are they available in the Citrix version of the technology as well?
Yes, they are.
Yeah, yep. And I say you guys, I think are sort of Citrix ready, and you've done all of that sort of stuff as well, haven't you?
Exactly.
Cool. Okay, so in the short answer is yes, it's identical. Okay, so last question we've got here at the moment is from Emre. The SolidFire guys are going to love this one. Do other vendors do Apache CloudStack integration? Yes, I know there are some other storage vendors who are looking to integrate with CloudStack. What we like here at ShapeBlue about SolidFire is these guys have really been leading the charge, and I think really we're the first storage vendor to realize two things. First of all, to realize, you know, this IOPS problem we have in cloud scale needs to be addressed, but also then to realize that they needed their platform, their storage platform, to be able to be integrated with a cloud orchestration platform like CloudStack, OpenStack, whatever it is. And, you know, there's a lot of vendors out there and all sorts of different things, not just storage, who are sort of saying, you know, our technology is great, it can be used in cloud environments. I get pitched at weekly by people trying to tell us this. And actually what SolidFire have shown is by actually going and leading the charge in terms of building the integration points into CloudStack, that they're serious about this. And yes, other people are working on things, I know that, but I really like the fact that SolidFire are sort of breaking the ground in respect to allowing their technology to be orchestrated, which ultimately is going to make for a lot more efficient, a lot more scalable clouds going forward. Okay, that I think is all of the questions we've got through. If anybody wants any further information on the back of this webinar, have a look at our blog. We'll put a piece up with links to the slides, which will be on SlideShare as well, and a recording of this if you want to pass it on to any colleagues. My contact details there, Geoff's contact details, or if you want to get in touch with the SolidFire guys, I didn't put your email up there. Just drop us a line and we'll pass your details on. So thank you to everybody who's turned up today. It's been a really good turnout for this webinar, and have a good evening, good morning, good night wherever you are in the world, and we'll see you next time. Cheers for now.